We have a rotation.
Okay.
Yeah. Once the end of rotation, then it's up.
It oscillates.
Oh, is it Mr. Meat?
Erases.
The base wasn't on
That was sticking back there. Whatever it is, it's not there.
Nobody can. Nobody's gonna get it. Face it towards the wall.
Oh, wait, yeah, after. Right after. Hey, long time for that.
Hey, you okay?
Okay, so we were talking about how to, all right, we were talking about how to define an x-intercept from the graph. You just look at it, that's where the line crosses the y-axis. Anybody remember how you find the y-intercept from a table?
Why?
When x equals 0. So you just go to the table, you scroll until you find x equals 0, and that's going to give you your y-intercept. From the equation, y equals mx plus b, you identify the b. If the equation is not in slope-intercept form, plug in 0 for x, then solve for y. Now, if we're explaining how to find an x-intercept from the graph, determine where the line would cross the x-axis. If we are looking for an x-intercept on the table, you're looking for the point y is 0. And if you have an equation, you plug in 0 for y and solve for x. All right. Okay, so this is finding the equation of a line. And if you're finding the equation of a line, there's several different ways to do it. It depends on what you're given. If you are given the slope and a y-intercept, that's the easiest of all. You just plug the values into slope-intercept. Y equals mx plus b. You just plug the numbers in. That's it. If you are given slope and the coordinates of a point, so you've been given slope and the point, then you use point-slope form. So y minus y1 equals m times x minus x1. Those are the two easiest because the name tells you exactly what you need. Slope-intercept form, you need a slope and an intercept. Point-slope form, you need a point and a slope. The next one, not quite as easy because it's a two-step process. If they give you 2 points, then I don't have a slope because all I have is 2 points, and I first have to calculate it. So I'm going to use the formula that we talked about yesterday, y2 minus y1 over x2 minus x1. Then you will use point slope. If you are given a table of data, if you have your calculator, you will do a linear regression. If you are not using your calculator, this is like a non-calculator activity, then you do it just like the one above it. If you've been given a table of data, then you have at least 2 points. Okay, we'll do some in just a minute, yes. Do what? Sure. I still have 2 people in here who didn't ever come finish it.
Oh, yeah. You can mark mine wrong, because I don't. Yeah, me too.
Okay, so now we have some special lines and special slope. Horizontal lines. What is the slope of a horizontal line?
But they can
Straight line.
The slope of a horizontal line?
0.
What about a vertical line?
Undefined.
So the equation of a horizontal line is going to look like y equals some number. The equation of a vertical line is going to be x equals some number. It's kind of backwards, a bunch of things, but that's how it works. Parallel lines. Can you tell me about the slopes of parallel lines? They're the same. So for example, y equals 2x plus 9 and y equals 2x minus 13. Those two lines are parallel. They're not the same line because they have different y-intercepts, but they are parallel. What about perpendicular lines? Anybody remember? Think about it for a second. Parallel lines go like this. If I want to make a perpendicular, I have to take one line, make it negative. It's flipped and switched. It's called a negative reciprocal. So for example, if I have y equals 5 halves x minus 3, the perpendicular line would be y equals negative 2/5 x plus 1. All you're concerned about on these is slope. So you take the slope, you flip it over and make it the opposite, or make it negative.
And then the B doesn't matter.
B doesn't matter. Okay, now with that in mind, that was like the quickest review of your entire 9th period here. So now let's do some problems. So they're going to give you some information, you got to find the rest of it. It says fill in the table of values, they gave you the line, just find some points from the, so here's one. Determine the slope. You can do it however you want to. If you want to use these values right here and do change in y, delta y over delta x, change in y over change in x, you can do that. Or you can count the slope, rise over run. Doesn't matter to me. Isn't it? Yes. Find the equation of a line. In this case, I could either plug it in my calculator, but that would take way too long because I have the slope and the y-intercept. So I'm just going to use slope-intercept form. Y equals 2x. Everybody okay so far? So far so good? You remember all this? All right. So now x-intercepts and y-intercepts.
The x-intercept is 2.5.
Yeah, it does look like 2.5. You need to write it as a point. So 2.50. And the y-intercept, we know that one because it was on the table. Anybody have any questions? So far so good. We remember 9th grade. Okay. Okay. Now they've given you a table of data, they want you to graph it. Graph it real quick. Okay, so after I graphed it, and then it said determine the slope, you can count rise over run if you want to. This time I did delta y, delta x. Find the equation of the line so I can identify my y-intercept from the graph. 7. Okay, so now, on the intercept, clearly I have my y-intercept, so I'm going to go ahead and write that one down because that one's clear. But your x-intercept is some sort of fraction, and it is not a half. So we actually are going to have to calculate this one from the equation. Remember how you calculate an x-intercept? Plug in 0 for y. So I'm calculating my x-intercept. So I've got, my equation is y equals negative 3x plus 7. So I'm going to do 0 equals negative 3x plus 7. Or 3x plus 7. So my x-intercept turns out to be 7/3. So I'll write that into 7/3. Everybody good? No. Did I lose somebody? We're all okay?
No, you lost me.
I lost you? No? Okay. Okay, this time they gave us an equation. It says complete the table of values, graph the function, write down the slope. In this case, let's graph the function first, because then you can just put your table of values for the function. Because we can graph it. They gave us a y-intercept and a slope. So 1, 2, 3, 4. Rise over run. This time it's fall over crawl because it's negative. Down 2 over 3. Is everybody okay? Does anybody have any questions on how I graphed that? Okay, and while I was graphing it, I happened to get some points, so I went ahead and put them in my table. It asks me to write down the slope. This is the easiest one of all for that. Slope's right in the problem. It's negative 2/3. And the intercepts, well, when I found mine, I actually ended up with both intercepts in the table also. So my x-intercept is 6, 0. My y-intercept is 0. Good? Yes? Questions? Awesome. There goes the easy stuff. Alright. Now no more pictures, no more graphs, which means no more rise over run. Okay, so now we're going to find the equation of the line, and this is where we're probably going to do something that you've never done before. We're finding it in both slope-intercept and standard form. Now you have to find slope-intercept form first, and then we'll convert it to standard form. So in this case, I have the slope, negative 1/2, and a point. Which formula should I use? Point slope. Look there. Point slope form. So that's the formula I'm going to use. So if you don't have it memorized, you should get it memorized because you'll need it for the rest of your mathematical course. So y minus y1 equals m x minus x1. ones without a subscript, nothing goes in those. They remain as x and y. You plug your x and y values in where there's the x1 and y1. Okay, so now I have y, I'm just plugging numbers in. Y minus 5, that's pink in here, equals my slope of negative 1/2. X minus negative 2. Minus minus becomes plus. So I have y minus 5 equals negative 1/2 x plus 2. There's nothing wrong with that. That is a perfectly acceptable equation of a line. And in calculus, a lot of times we leave them this way. However, they told us that we had to put it in slope-intercept form and standard form. This is neither. This is point-slope form. So I have to go ahead and distribute my negative 1/2 and move my 5. Everybody good? So I'm going to distribute negative 1/2. So that would be y minus 5 equals negative 1/2 x. What is half of 2? Okay. Now you're not quite finished because the 5 is in the wrong place. So now we have to add 5 to both sides. Yes. All right, there is my slope-intercept answer. Now we have to put it in standard form. So if you look back at the very beginning, let's remind ourselves what standard form looks like. Standard form is ax plus by, so x and y are going to be on the same side together, equals some sort of constant. And here's the really important piece. No fractions, and a has to be positive. So first, let's deal with one thing at a time. Currently, my x and my y's are on separate sides. I have to get them together. So I'm going to move this x to the other side. What happens when I move negative 1/2 x to the other side? It becomes positive. I'm going to come over here and do it. So I'm taking this, moving it over. That makes it positive 1/2 x plus y. Now you're almost there. The only problem is this contains a fraction. Standard form can't have fractions. So we'll just clear the denominator. Does anybody remember how to clear denominators? No, it cannot be a decimal. What? Multiply by the denominator. Now, I need to multiply every single term by the denominator. So my denominator is 2. I'm going to multiply everything by 2. So I'm going to multiply this by 2, and this by 2. Multiplying the first term by 2 just cancels the denominator. That's why we did it. So it's 1x, but we'll just write x. Plus 2 times y is 2y. Equals 8. That's your answer in standard form. Any questions? Okay, we'll do several more, so you'll get used to it. Okay, the next one says I have 2 points, 2 and negative 3 and negative 6 and 1. So my little chart tells me that if I have 2 points, there it is. If I have the coordinates for 2 points, then first I have to use this formula, and then I have to use this formula. So first I'm going to use my slope formula. y2 minus y1 over x2 minus x1. You can label these points however you want. It doesn't matter. It just makes sense to me that this one's listed first. So it'll be x1, y1, and this one will be x2, y2. Plugging numbers in formula. So 1 minus negative 3 minus becomes plus. Negative 4/8 is the same thing as negative 1/2. Now that's your slope. Now I'm going to use point slope form. So y minus y1 equals mx minus x1. It makes no difference which of the 2 points you plug in here. Now I've already labeled them, so it would make sense to use the one that's labeled x1, y1. But most of the time, and it just works out this way that it is the smaller of the two, most of the time I choose the one that has the smaller numbers. Or if one of your 2 points has a 0 in it, use that one because it's easier. But otherwise it doesn't really matter which one you use. Okay, so I'm plugging now my slope of negative 1/2 and one of these 2 points into the formula. Doesn't matter which one you choose. I'm going to use the one that I already labeled as x1, y1. So y minus negative 3 was negative 1/2 x minus 2. So that makes this y plus 3. I'm going to go ahead and distribute the negative 1/2. So I get negative 1/2 x plus 1. Now we have to put it in slope-intercept form. So I need to subtract the 3 from both sides. So I end up with y equals negative 1/2 x minus 2. Now that's one of your answers. That's slope-intercept form. But I still need it in standard form. So remember, standard form, x and y are on the same side together. No fractions for that leading coefficient, or your a value. So I'm going to move my negative 1/2 across, it's positive 1/2, x plus y equals negative 2. Now I need to clear the fraction.
So you
Multiply everything by 2. So you end up with x plus 2y equals negative 4. So far so good? Okay. Next, it says contains point 0.04 and is parallel to y equals 2x minus 3. Now first of all, 0.4. Anything special about that? It's what? It's a y-intercept. So they actually gave me the y-intercept and they gave me the slope because it said that this is parallel. And remember, parallel lines share a slope. So it's parallel to this slope too. So I have my slope and my y-intercept. So this one's super easy. I know my slope is 2. I know my p-value is 4. So I have y equals 2x plus 4. That is your slope-intercept answer. Standard form. X and y have to be together on the same side. So I'm going to move that 2x over. When I do, it becomes negative 2x plus y equals 4. Small problem. You can't have a negative a value, or the one that's with your x can't be negative. So okay, though this is an easy problem to fix, you just change the signs on everything. So I'm going to make that positive 2x, which means it has to be minus y equals negative 4. So far, so good? Any questions so far? Speak now, prayer poetry, please. We're good? Okay. Alright, next one. Contains a point negative 4, 5. This time it is not a special point, it's a regular point. And it says it's perpendicular to 2x plus 3y equals 7. Now, perpendicular, remember that's a negative reciprocal slope. Problem is, I can't even tell what my slope is. So what do I need to do first? I need to solve this one into slope-intercept form. Yeah, get y by itself. So If I get y by itself, get this into slope-intercept form, then I'll at least have my perpendicular slope, and I can fix that. So let's do that first. You do it. You know how to do this. Okay, so that was easy enough. I moved my 2x over, and then I divided by 3. I don't really care what the y-intercept is. It doesn't concern me. All that matters to me is this slope right here. And that's my perpendicular slope. So that's not even the slope I'm going to use. I'm going to take that slope, flip it, and change the sign. So I'm going to use positive 3/2 into this point. And plug it into point slope form. Y minus y1 equals m x minus x1. Y minus 5 equals 3/2 x minus, yes. Now we have to put this into slope-intercept form, so I'm going to distribute. Six. 2 is in a 4, 2 times 3 is 6. Or 3 times 4 is 12, divided by 2 is 6. So I had to add 5, and I get 3/2 x plus 11 as my slope-intercept. I still need standard form. Move it across, got to get x and y on the same side together. That fraction, so I'm going to multiply everything by, you can multiply it all by -2, and that'll take care of the negative at the same time. That will leave me 3x, because the whole reason we did it was to clear that first fraction. Minus 2y equals negative 22. Okay, everybody good? So you just made it through the hard ones. The next 3 are really easy. First of all, they give me a point, and then they say it's perpendicular to y equals 3. Well, if they say y equals 3, what kind of line is it? Horizontal, which means a perpendicular line would be vertical. Vertical lines are x equals a number. Remember we did that. It says special lines. Horizontal lines are y equals a number. Vertical lines are x equals a number. So this has to be x equals something. What should it equal? 5. It has to equal 5. Because it contains this point. And the only way it can contain 0.51 is if x equals 5. Yes? Okay, so this one, parallel to y equals 3. So that is a horizontal line. If it's parallel to that, what kind of line are we dealing with? Another horizontal line, which means it's going to say y equals a number. What number? Okay? I know, I like that. But I promise you'll forget. Everybody always forgets these, I don't know why. Perpendicular to x equals 4. What kind of line is x equals 4? Vertical. So if it's perpendicular to that, horizontal. And it would be y equals -7. All right, y'all good?